All right. So, good morning, good afternoon, everyone. I would like to welcome everyone to the webinar series of the Women's Network from SCG. Today, we have Lauren Haygood, and she will be presenting the intersection of water quality, public policy, and sustainability. I'm going to read a little bit about her so we know. About Lauren, she's a PhD candidate in the Boone Pickens School of Geology at Oklahoma State University. She previously earned both her bachelor and master in geosciences at the University of Tulsa, where her thesis focused on completing biogeochemical analysis of the Kiamichi River Basin in the southeast Oklahoma. She's currently investigating deep sea sediments recovered from the Scotia Sea during RV Polar Stem PS 119 expedition, as well as from the Iberian Margin during the Expedition 397, of which she's a shore-based scientist. Outside her research, Lauren is actively involved in science policy, science communication, and community engagement. She also serves on science policy committees of geoscience organizations and has experience leading a water quality community science initiative in Oklahoma. Lauren is also involved in mentoring students in geology and research and has experience selling as a graduate student mentor for the STEM Seas expedition on the EV Nautilus. So with that, I would like to welcome Lauren, and we're very happy to have her today. So the presentation is now on your side.
Okay, cool. Thank you. And thank you for having me for this webinar. I'll be talking about the intersection of water quality, public policy, and sustainability. Okay, so just kind of an overview of what I'll be talking about. Kind of talking about the objectives of doing this work, touching briefly on Oklahoma politics, and then also going into water quality in Oklahoma and talking about examples of science communication that have been initiated in order to kind of work in this intersection of water quality, public policy, and sustainability. And then also touching on the role of geosciences and the UN Sustainable Development Goals, or SDGs, and then also just some like future directions of where this might be going. And so kind of for the objectives, scientists have an important role within society where we collaborate with multiple different audiences, as well as trying to share the outcomes of our research. In Oklahoma, there has been a gap between different stakeholder groups due to a variety of reasons. And so it's kind of what trying to illustrate in the box over here. And some of the questions coming up from this gap is just how can we as geoscientists bridge this gap and kind of get us to where we have policymakers, scientists, and community members all working together, and how can this connection advance sustainability as well as influence public policy. And so just touching briefly about Oklahoma politics, the map kind of breaks down the different congressional districts that we have. So we have 5 different congressional districts. We have 101 state house districts, and then we have 48 Senate districts. And then just kind of what was said before, we have a gap between community members, scientists, and policymakers. And the gap kind of consists of different factors such as misinformation, jargon, such as using technical language that might not be understood by everyone, differences in incentives and expectations, as well as differences in politics and just different viewpoints with like infrastructure and water in Oklahoma. And so that kind of brings us into Oklahoma water quality. And so in this animation, I am illustrating data published in the Integrated Water Body Reports for Oklahoma. These Integrated Water Body Reports are published every 2 years. The red segments are designated EPA Category 5 impairments, so that means they're polluted with at least one designated use not being supported or threatened. And these designated uses can include things like recreation, so like if you wanted to go swimming in a particular water body, it might include drinking water, whether that water is being used to support kind of like what we get out of our taps. And then also aquatic life and whether like fish and mussels and other aquatic organisms might be able to survive in the water. The impairments or pollutants can include things such as oxygen content, bacteria like Enterococcus, which is a fecal-derived bacteria, as well as E. coli. It might include things like heavy metals, as well as other additional pollutants. Basically, it's just kind of a summary of metals, physiochemical parameters like the oxygen content of bacteria, microbes, as well as fish bioassessments. So the impairments aren't specified in this animation, so this is just kind of a high-level summary overview of all the potential impairments that are in Oklahoma's water bodies. And basically in 2020, I began receiving multiple messages about water quality related jargon, as well as legislation from multiple communities and people in Oklahoma, just wanting to get a better understanding of water quality and kind of how that was impacting like their everyday life in Oklahoma. Um, I did an extensive search about what community resources were available when I started getting these questions and saw there was a need and an opportunity to do something about water quality in Oklahoma. There wasn't a community science project that I was aware of that dealt with metals and water when I first decided to initiate this project, and metals and water was a public concern for communities in Oklahoma. Just kind of getting a better understanding of what's in our water. And additional components leading to this project included the opportunity to help fill in data gaps, which would lead to more effective water policies. This also provided the opportunity for science communication and the possibility to highlight sustainability. And so I decided to partner with communities to work towards bridging a potential gap between communities, policymakers, and scientists, and kind of give community science a go. And so with community science, I have some pictures from some excursions that we've done. This here is a freshwater mussel shell that was washed up on the banks of one of the water bodies. But the main goal of community science was to empower communities to get involved in water science and policy action. And since 2020, we have had more than 500 people involved. I kind of stopped counting after that. This also coincidentally wound up addressing some of the UN Sustainable Development Goals, which I'll discuss later on. And with more in depth with community science, I'm kind of showing a map again of Oklahoma with the different congressional districts broken out. But these are just two examples of where we've done community science at. So we have up in Northeast Oklahoma in the Tri-State Mining District, and then we also have down in Tulsa County along the Arkansas River. There are more water bodies that we investigated and more counties we went to, but these are just two examples that I decided to show. And at least with this community science initiative, it was started to educate the public and communicate with legislators about water quality and its relationship to infrastructure. So for example, with that is in Tulsa County, there is a project of building this dam and kind of creating more of a lake environment. And so there was public concern about how that would impact water quality and common known pollutants in the Arkansas River. And so we went out and we're measuring different water quality parameters. And each site and water body was community driven. So it was kind of developed like community members would recommend places to test the water at. And so they were in full control of where we sampled water at. And the idea behind this is that people learned about different water sampling techniques. We would also break down jargon and kind of explain that technical language. And all data collected was made publicly available, and that could then be used in watershed planning. And essentially, the motive was also to empower communities, not just with a science process, but also providing them tools and resources for them to be involved in the policymaking process and like talking with legislators. And more specifically, it involved trainings that would teach people how to collect surface water samples, as well as discussing the data that we gathered and what it meant in terms of public health and aquatic ecosystem health. And if people were interested, they could take a mini test kit with them so they could test water samples of their own interest. And we also included discussions and information on public policy. And this way, it was just kind of a whole rounded way of empowering community members to engage with their local or federal policymakers about water related issues in Oklahoma that there were concerns about. And since starting this community science project, there's actually been some grassroots organizations that formed that are continuing with this water quality monitoring, which I think is great to see and kind of a really cool ripple effect. And with the community science, it also turned into classroom partnerships, which got K through 12 students involved in the project. We've had students develop their own science fair project using the publicly available data, and or they chose to generate data of their own to present. And we've also had undergraduate students join in and help gather data, as well as complete an undergraduate research project that they presented at a local conference. And so, with that, kind of also tried to dive into more virtual materials and workshops, especially with the COVID-19 pandemic, as well as considering ways to reach a more wider audience and make more of this accessible. I kind of turned to virtual ways of communicating science and public policy, and I've listed some examples on the slide, such as ArcGIS story maps, virtual field explorations, webinars, and workshops. With the ArcGIS story maps, each spring since 2021, I do a call for submissions for It's a Waterful Life, because I thought it was a little punny name to give the story map, but people can submit a water body. It used to be only rivers, but I've since evolved it to include water bodies, including oceans. So pretty much all these listed over here. You can submit. There's even the other option. So if it's not listed, you can still submit it. And then people can also submit key issues, what people can do to stay up to date about the particular water body and or help out, and any other relevant information, such as like ongoing legislation related to it. Really, it's just a way to share about policy, conservation, and just share about a water-related body anonymously that you want others to know about. And initially, it started out targeting Oklahoma submissions, but it's since grown to include multi-state and international submissions as well. So the example on the slide is from a lake in New York, but water bodies such as the Kiamichi River, Arkansas River, Illinois River are all from Oklahoma submissions. Another example would be the field exploration done virtually. Obviously, I'm not the first person to generate something like this, but basically just involve creating Google Earth and Google Map files where people can virtually explore various water bodies of Oklahoma. They can explore the surrounding geology and ecoregions, as well as additional parameters. We have accompanying worksheets to go along with these. And this also kind of turned out to be a useful way of making connections between water quality and outside factors, like kind of what's your surrounding geology? Are there maybe like natural causes to the water data that you're seeing? Additionally, like webinars also proved to be successful, hosting different speakers with diverse backgrounds that could share their work and how scientific studies were being conducted and utilized to develop water-related policies. In 2021, I started doing geology workshops, and in 2022, added in topics of oceans and climate. So kind of went from doing freshwater to having freshwater, more like saltwater, like the oceans, and then tying into climate. We have activity booklets with these that have specific activities for the target audience. We go through different hands-on learning activities, including activities where we'll generate data and participants can come up with a hypothesis and test it. We've also touched on like bathymetry for high school students, where they learned about ocean bathymetry and the UN Seabed 2030 plan. So kind of maintaining like the UN SDGs and sustainability. And through these initiatives, also like emphasis was placed on sustainability and kind of how our actions can have an impact on the environment. And that kind of brings us into the UN Sustainable Development Goals. So, like previously, the Community Science Initiative and some of the virtual activities kind of wound up addressing a few of the United Nations Sustainable Development Goals. And there are 17 UN Sustainable Development Goals. However, throughout working at the intersection of water quality, public policy, and sustainability, we've primarily kind of addressed 4 of them. One being number 6, clean water and sanitation, which is ensuring availability and sustainable management of water and sanitation for all. The other is number 11, make cities and human settlements inclusive, safe, resilient, and sustainable. Number 13, taking urgent action to combat climate change and its impacts. And then number 14, conserve and sustainably use the ocean, seas, and marine resources for sustainable development. Although number 6 is the one we primarily addressed, the other 3 were also kind of addressed minorly with community science and the workshops and the virtual methods of getting people involved in water quality and public policy. And that kind of brings it into the role of geosciences as well. So, like what was previously mentioned, scientists have an important role within society just because we collaborate with multiple different audiences, as well as trying to share the outcomes of our research. In general, geosciences plays a pivotal role in bridging public policy gaps. As geoscientists, we are studying anything from structures, engineering, the subsurface, water, oceans, energy resources. It's really an endless list of what we do and what we study as geoscientists. We also have an expansive network, and we collaborate with industry professionals. We collaborate with academia and academics. We collaborate with policymakers. We also work with the general public. Again, there's like an endless list of people and groups that we work with. And so geoscientists really play a pivotal role in bridging the public policy gaps. And more specifically, kind of like our role can help build trust within these different groups. And geoscience techniques can be applied to develop and sustain science communication and science policy efforts, which can thus address the United Nations Sustainable Development Goals as well. Maybe not all 17 at the same time, but different projects that we do can address 1 or 2 or more of these SDGs and kind of shed light on sustainability. And just to kind of like highlight an example or tie it back into some of these science communication examples, I'm going to highlight geochemistry. So water quality isn't necessarily good or bad, but it's rather evaluated dependent on the type of use. So, for example, is the water body being primarily used for drinking water? Is it primarily being used for recreational purposes? Is it primarily used to support and sustain aquatic life? And with the focus on metals and physiochemical parameters, it's important to have a geochemistry focus. Um, just because water quality can be dependent on like the geology of the area, chemical interactions, as well as having outside sources that it might be anthropogenic or non-anthropogenic. And so it's kind of important to discuss the geology of the area of the water system of interest that water body is cutting through, as well as addressing different geochemical interactions that could be occurring, which also includes potentially identifying methods to determine whether a parameter might be naturally occurring or might be sourced from anthropogenic input. And so kind of like results with this and a little bit into the future directions. Um, we've been working at the intersection of water quality, public policy, and sustainability. This included a few community science initiatives that were both in person and virtual, all of which kind of had the goal of reaching different audiences and also had different end results. And so, for example, with community science, it provided generated data to be incorporated into watershed planning. It helped work towards breaking down jargon and covered different sampling and measurement techniques. Workshops provided more hands-on learning opportunities. Virtual science communication provided a more accessible method of engaging more people in the geosciences and raised awareness of key issues pertaining to water quality. And then additional outcomes included the development of research projects for undergraduate and high school students. We've had science policy advocacy and community empowerment also be additional outcomes. Um, and so basically, we weren't just disseminating research and results, but we're also providing educational opportunities, research experiences, empowering communities, and providing support towards science policy. And throughout these initiatives, 4 primary UN Sustainable Development Goals were addressed. And we've even had a few water policy wins in Oklahoma, since starting all of this work. And really diverse science communication techniques have provided the opportunity to engage with these audiences and share about earth and water science in Oklahoma. And that can be used to inform about public policy and can also result in sustainable efforts and highlight sustainability, especially in future practices. And so kind of also want to highlight getting involved, just because small actions can cause big ripples, and there's lots of ways to get involved with like your community or at the school you're at, and even implementing a project if that's something that you might be interested in. Really, the key is just getting started and taking that initial first step. And there's lots of programs and organizations to get involved in, including SEG as well as others. And so if you're interested, I highly recommend just getting involved and seeing how you can kind of take the first step into getting involved with your community or local organization. And I'd like to acknowledge a lot of different groups of people, the American Geophysical Union, their local science partners and Voices for Science program. For community science, I got a grant from the Voices for Science program, which helped me get the supplies needed for it. So really thankful for that, as well as the team-based organizations that AGU does. I would also like to thank the Soil and Water Conservation Society, the Department of Geosciences at the University of Tulsa, just because I started some of this work while I was wrapping up my master's degree at TU. And then also want to thank Boone Pickens School of Geology at Oklahoma State University, just because with transitioning universities, wasn't quite sure how much of this I would be able to continue, but professors at both TU and OSU were incredibly supportive. So it really provided a good environment for me to continue this work and kind of build off of what was started at TU and able to add on more and build on that. Also like to thank community members and groups, just because you can't do community science without the community. And so I'm really grateful that they brought up these questions and were interested in getting involved. It really meant a lot. And then also want to thank grassroots organizations, for being involved as well. And then K through 12 Oklahoma students, as well as policymakers, just because there are a lot of different groups that needed to be involved, and really grateful for all of them for getting involved in this with me. And I also have a picture on the right, which is I virtually Zoom with classrooms and groups as well. And we were talking about water quality and the role of freshwater mussels in helping mitigate water quality. And one of the students made a Lego set, and said it was me. And so kind of tying back to the fact that like small actions can cause big ripples, just kind of taking that first step. You never know who you might influence, or what components you might address. And so kind of just wanted to throw that out there. Um, and then I also want to say thank you. And if you're interested in learning more, I'd recommend reading the Geoscience in Action report. It features a lot of geology projects that address United Nations Sustainable Development Goals, including some of the work shown here in Oklahoma. So if you're interested, I definitely recommend checking it out. It's publicly available and free online. The PDF is downloadable, but it's really good wealth of project information. And if you have questions or comments or anything, I'm happy to chat more. Thank you.
Thank you, Lorraine. This was excellent. Do you have any questions, anyone? You can either type them, or I don't know if Paula allowed to get the mic on. No.
Yeah, I can do that, but I don't see any hands
Any questions?
raised.
Well, okay. I can ask you questions. Obviously, that all starts with the technical part on this project, right? And then as slowly you divert more on the social side and links to the sustainability goals, which is wonderful. What did you find it was the most interesting part that you might have not expected this at the beginning?
Yeah, that's a good question. I think the most interesting part, to me was, I think because some of the sites we would go to would be like really close to each other, and I think just seeing like how different the data we would get back with some of those sites would be, I found that really interesting. And then kind of having to work with people and figure out why that might be the case, I found that really interesting because every time we go out, it would almost be like trying to solve like another puzzle. Like, oh, we got this! Like, what does this mean? And trying to figure that out. So that was really interesting.
And what about challenges then you did face and you were not expecting?
Yeah, with challenges, I think initially the first challenge I kind of faced was being a master's student and just kind of being like, I want to do a community science project, which means I need people to like come out and be involved in this. And just kind of getting started with that because I feel it's kind of almost like having with imposter syndrome where you're kind of like, I don't have a career. I'm just a student, but I want to do this and get people involved. And so initially, I think that was a challenge of just kind of telling myself like, okay, I can do this. Like, I'm a student, but I can do this. Like, I have the knowledge. We can do this, and doing that. And so I think that was one of like the biggest challenges to like kind of like work through and kind of like be like, yeah, we can do this. Like, we've learned this, we studied this. Like, we can do this.
Yeah, no, it's interesting you mentioned this one because at the end when you start giving the knowledge, I saw there is so many communities. How did you do for a period of time to coordinate all this to get people involved? And actually, it's a challenge that you're mentioning. So it's a kind of a circle.
Yeah, yeah.
Well done. I can see there is a question from Pallavi. How did the idea for this work came about? Did you take examples or inspirations from an early work you done or from someone else?
Yeah, I think inspirational wise, at least with like water quality and policy, and even science communication, with the Voices for Science cohort that AGU does, they have a new cohort every year, and they kind of like will have previous year people kind of share their projects that they've worked on and stuff previously. And I think seeing the fact that there are people who kind of just took a leap with something and tried something new, that was really encouraging and really inspirational, just because that might not necessarily be like, that wasn't necessarily my first thought of like, I'm gonna go do something completely new. But seeing that other people had done it, I was kind of like, okay, if you can take this leap, then, you know, I can try taking this leap too. And then also Erin Brockovich, also, I find to be really inspirational, just because she's been a huge advocate with different water related policies and water quality like across the US. And so I find her also really inspirational.
Good. So Jim Pendret, I hope I pronounce this well. It says, thank you, Lorraine, for your insight. Is there an organization from your list that would provide water quality testing kit for conducting citizen science with high school students?
Yeah, think I think there's a lot of different, I guess, kind of like groups kind of doing that now. Like we have there's an NSF funded project throughout the Boone Pickett School of Geology that some professors are involved in, where they have high school teachers work on a water and geoscience related project. And that started like fall 2022. There's also Blue Thumb in Oklahoma, which at least like they can train you on being a stream monitor, and they kind of focus more on like the biological aspects of water systems. Um, and then with more of like the national organizations, like with AGU, they do like calls for people to join their programs like Voices for Science and local science partners, like in the fall and spring. And if you apply and you get in, then you have access to like their resources and everything. And they also have a lot of publicly available information as well. If you go to like the Sharing Science page on AGU's website, they have a lot of resources for kind of getting involved in this stuff too. So I think there's a lot of stuff out there. It just kind of depends on what angle of getting high school students involved you wanna take.
I think, oh yeah, I think that's fine. Just some ideas I was going through, right? I spent almost a decade living in Asia, where you cannot drink and you cannot even brush your teeth from the tap water. And that involves also an issue with the plastics, because you drink plastic, well, water from the plastic bottles, and a big pollution. So I find this fascinating. And I think I already told you before that I'm an advocate for all this. Yeah. Anything else that you want to share before we closing? What do you learn from this? What's next?
I think like with what's next, I'm trying to I guess incorporate more, I guess kind of like build off of this, but kind of incorporate more things related to the oceans, and kind of, I think like for me, my main focus areas are like water and like climate related. And so trying to incorporate more things into oceans and marine side of things, while also kind of maintaining the freshwater side of things that we've been doing, and just kind of advocating for different like public policy initiatives that'll kind of be beneficial for water quality in Oklahoma. So I guess kind of like maintaining the status quo, but also trying to add on like a little bit more. So we'll see.
Well, thank you, and thank you for participating. And I wish you all the best on the new adventures.
Thank you. Thank you. Thanks for having me.
Yeah, excellent. Thank you everyone for attending.